Well, we're in the final stages of completion of Optimus 3, which is really going to be by far the most advanced robot in the world. Nothing's even close.
Yeah.
Um, in fact, I haven't even seen any demos of robots that are as good as Optimus 3, frankly.
This definitive and heavily coded statement from Elon Musk has just ignited a frantic industrial race, forcing Tesla to wager everything on a high-stakes gamble. The suffocating paradox lies in the fact that while Musk asserts Optimus is in its final stages of completion, and the number of robots performing actually useful work inside their factories remains at zero, Tesla is quietly stockpiling a massive volume of components valued at $685 million, enough to assemble nearly 180,000 robots immediately. What exactly is this contradiction hiding? Could a top-secret mechanical overhaul on the V4 design have just been triggered? And will the current brutal production grind be enough to help Tesla achieve the unthinkable goal of scaling capacity to 1 million Optimus robots per year, right in this very phase?
Yeah, I think we'll start production on Optimus 3 this summer, but very slow at first, and then probably reach high volume production around summer next year. We'll have Optimus 4, design complete next year. I try to release a new robot design every year, an improved robot design every year.
The first core upgrade lies in the comprehensive restructuring of the physical powertrain system as it transitions from the early V3 prototypes to the commercialized V4 design, directly solving a grueling mechanical riddle. How does a 57-kilogram robot endure tens of thousands of impact cycles on a factory floor without suffering power failures or fractured joints? The answer is a radical engineering pivot. Tesla has completely eliminated expensive but fragile harmonic drive systems from heavy-duty joints like the hips and dual shoulders, replacing them entirely with cycloidal reduction mechanisms that boast ultra-high torque density and exceptional shock absorption. Only the wrist joints retain the lighter harmonic architecture to optimize computational inertia.
There are really only three hard things for humanoid robots. The real-world intelligence, the hand, and scale manufacturing. Yeah. I haven't seen any even demo robots that have a great hand, like with all the degrees of freedom of a human hand. But Optimus will have that.
The most astonishing breakthrough, however, belongs to the new Gen 3 hand system. Component density has been compressed by 4.5 times compared to previous generations, relocating all 25 actuators up into the forearm to pull a biomimetic tendon system. This upgrade raises the hand's degrees of freedom DOF straight from 11 to 22 and integrates thin-film tactile sensors at the fingertips, unlocking the dexterity required to manipulate over 3,000 intricate tasks. From stacking 4,680 battery cells to handling fragile, thin-shelled eggs without breaking them. This structural shift at the near-atomic level is pushing Tesla's recruitment engine and physical mega-construction sites into a state of red alert. Job descriptions for on-site motor design engineering roles are fiercely focused on industrialization, stator design, and electromagnetic optimization to dramatically shorten the cycle from laboratory to the pilot production floor. This ravenous appetite for human capital is directly proportional to the speed at which massive steel structures are rising. At Giga Texas's 5.2 million square foot North Campus expansion, drone field surveillance confirms that construction crews have already erected the first 4-story structural steel frames for the dedicated Optimus factory, while continuously pouring foundations and executing large-scale land reclamation to the south to prepare for the hyperscale target of 10 million units per year. However, integrating thousands of robots into an automated assembly line would be an absolute energy disaster without an equally capable processing brain, leading to a challenging bottleneck. How does Tesla plan to train a colossal mechanical army without crashing regional power grids? Right next door to the Optimus factory. The Cortex 2.0 AI cluster has just gone live with its first 250 megawatt phase, devouring hundreds of thousands of NVIDIA H100 and H200 GPUs to run pure vision-only models. To shoulder this immense electrical load, Tesla is relentlessly dragging power to the site ahead of schedule. This month alone, 18 brand-new Megapack blocks were craned onto permanent supports, advancing the total scale toward 260 dedicated Megapacks for Cortex 2.0 to store nearly 1 gigawatt-hour of electricity. Remarkably, the trademark registration for Megapod serial No. 99,893,717 filed on June 18, 2026, a modular, self-contained, liquid-cooled data center system, proves that Tesla will deploy these AI computing stations directly at supercharger locations by draining underutilized grid headroom from the 7 gigawatt of available capacity during off-peak hours. Tesla will run fleet optimization algorithms for digital Optimus via custom AI-5 chips, turning the vehicle charging network into a massive distributed supercomputer. All of these spearheads are being pushed at a breakneck pace to converge on a brutal mass production timeline, to suffocate the six-figure per-unit costs of its competitors down to a commercial target price of $20,000 to $30,000. Tesla has tightened the screws on its multi-layered supply chain pyramid, forcing Taiwanese manufacturers like Allied Group, Merle Automation, and Asia Optical to accelerate the delivery of harmonic dampers and advanced aspherical lenses for the robot's vision system, to bypass geopolitical embargoes and supply bottlenecks. These partners had to immediately form a joint venture with Shenzhen Kadali Industrial, deploying 1.667 billion renminbi to construct the Kedion factory in Rayong, Thailand, utilizing an existing facility to export core joint modules by the second half of this year. This synchronized flow, stretching from Southeast Asian components to Texan supercomputers, is clearing the path for the transitional V3.5 version to run validation tests before freezing the final V4 design in December of this year. Back in Fremont, the factory floors have fully wrapped up retooling to shift to Optimus 3 production with an initial capacity of 1 million units per year as early as this coming July or August, standing fully prepared to detonate the largest human labor replacement platform in the history of industrial civilization. This may be the most important question surrounding the entire Optimus Gen 3 project today. Who is Tesla going to sell 1 million humanoid robots per year to? The question has become even more pressing following reports that Tesla has placed a massive $685 million components order with Sanhua Intelligent Controls in China for linear actuators used in Optimus. According to industry sources, these components are sufficient to produce approximately 180,000 humanoid robots, with deliveries expected to begin in the first quarter of 2026. If these reports are accurate, this would represent one of the largest robot-related orders in the history of the humanoid robotics industry. What makes this particularly noteworthy is that the scale of the order far exceeds anything Tesla has previously discussed publicly. Elon Musk previously stated that Tesla aimed to produce around 10,000 Optimus robots during the initial phase of deployment. However, if the newly ordered components are indeed enough for 180,000 robots, the potential production volume would be approximately 18 times greater than the original target. This suggests that Tesla may have completed most of the development work on Optimus Gen 3 and could be preparing to enter true mass production rather than remaining in a limited pilot production stage. Many industry observers believe that the third quarter of 2026 could mark the point at which Tesla significantly accelerates Optimus production. If the first-generation production line is launched on schedule, annual robot output could increase from a few thousand units to hundreds of thousands in a relatively short period of time. Compared to the original target of 10,000 robots, a production level of 180,000 units would represent a 1,700% increase. This is the kind of manufacturing ramp that very few humanoid robotics companies have ever achieved. These developments also align with statements Tesla made in its recent shareholder report. The company stated, "Preparations for our first large-scale Gen 3 factory will begin in Q2. The first-generation line, designed to produce 1 million robots per year, will replace the Model S and Model X production lines in Fremont. We are also preparing Gigafactory Texas for a second-generation line designed for a long-term annual production capacity of 10 million robots." This statement demonstrates that Tesla is betting on Optimus at an unprecedented scale, rather than using Fremont factory space to build approximately 40,000 Model S and Model X vehicles annually. Tesla intends to use that same footprint to manufacture up to 1 million robots per year. It is an extraordinarily bold transition because it implies that Tesla believes future demand for Gen 3 could eventually surpass demand for its premium electric vehicles. However, the key question is not whether Tesla can build 1 million robots per year. The real question is whether Tesla can find enough customers to buy them. Interestingly, the answer may be far broader than most people realize. The first and most obvious customer is Tesla itself. Across its factories, Tesla employs tens of thousands of workers performing repetitive tasks such as material handling, component transportation, quality inspection, and production line support. Even if Optimus replaces only a portion of these tasks, Tesla could potentially deploy tens of thousands of robots within its own operations. Elon Musk has repeatedly stated that Tesla will be the first major customer for Optimus before expanding sales to external buyers. The second major customer group is likely to be industrial manufacturers. Around the world, millions of factory jobs involve repetitive physical labor, labor shortages, and rising wage costs. Unlike traditional industrial robots that are confined to fixed stations, Optimus is designed to operate in environments already built for humans. This means manufacturers could potentially introduce Optimus without completely redesigning their facilities. If only a small percentage of global factories purchased dozens or hundreds of robots each, demand could quickly reach hundreds of thousands of units annually. Another enormous opportunity lies in logistics and warehousing. Companies operating fulfillment centers, distribution hubs, and supply chain networks spend billions of dollars every year on labor. If a $25,000 to $30,000 Optimus robot can operate nearly 24 hours a day, 7 days a week, it could become economically attractive for warehouses handling millions of packages. Large logistics operators could potentially deploy thousands of robots across multiple facilities, creating demand at a scale few people currently appreciate. Retail is another potentially massive market. Large supermarkets, retail chains, and distribution stores require workers to stock shelves, move inventory, organize storage areas, and transport goods throughout facilities. A humanoid robot capable of performing these routine tasks could help businesses reduce labor shortages while improving efficiency. Given the sheer number of retail locations worldwide, this market alone could eventually account for hundreds of thousands of Gen 3 units. Longer term, elder care could become one of the largest opportunities of all. Aging populations are creating severe labor shortages in caregiving industries across many countries. A humanoid robot capable of assisting elderly individuals with basic daily tasks, mobility support, medication reminders, and household assistance could provide significant value. While this market may not drive initial Optimus sales, it could eventually become one of the largest sources of demand in the future. Consumer households may ultimately represent the largest market, but they are unlikely to be the first, at an expected price of roughly $25,000 to $30,000. Optimus will initially be beyond the reach of many families. However, Tesla's long-term strategy appears remarkably similar to its automotive strategy: scale production, reduce costs, and continuously improve capabilities. If Tesla succeeds, future versions could become affordable to millions of households seeking assistance with chores, caregiving, and everyday tasks. Even so, many questions remain unanswered. Optimus has yet to demonstrate that it can reliably perform a wide range of complex tasks in real-world environments. The robot must become fast enough, intelligent enough, safe enough, and dependable enough to replace human labor across numerous applications. If Tesla fails to achieve these goals, selling hundreds of thousands of robots every year could prove extremely challenging.